Solving systems of linear equations in two variables by addition method. As always, let's recall the solution form, which is x, y, x in the first position and y in the second position. Now, the idea of addition method is that if we add the equations of the system, one of the variables will be eliminated. So let's look at the problem 1 and let's do what the method said. So if I want to add both equations of the system, one of the variables will be eliminated. Let's see now. To add the equations of the system, I have to add x together, y together, and the constants together. Now, 2x and negative 2x is 0. Why? Because the coefficient of x are opposite numbers. So I have positive 2 and negative 2 together. This is 0, and 0 times x becomes 0. So x is gone. 5y and negative 3y is 2y. 1 plus 7 is 8. So eliminating x, I am left with an equation only in y. So I know how to solve this equation. Dividing by 2 both sides, y is 4. So since I am able to find a value for one of the coordinates of the solution, this means this system has only one solution. So the solution is waiting for its values. Y is in the second place. So now I have to find what is x. And to do this, to find x, I have to choose one of the equations of the original system. So let me choose the first one. You can choose the second, it doesn't matter. Still, we have to find only one value for x. So let's write 2x plus 5y equals 1. And let's substitute y with 4. So let's replace y with 4. And we have 2x plus 5 times 4, which is 1. So I have 2x plus 20 equals 1. Removing 20. By subtracting 20 to both sides, I have 2x equals to negative 19. And dividing by 2, x becomes negative 19 over 2. Okay? Therefore, the solution is negative 19 over 2, and the value of y is 4. Now, in order this point will be a solution to the system is when the values of x and y substituted into both equations will give me true statement for the system. Now, I will check the solution only in these first examples. For the other, I am not going to check the solution. Now, this is what I declare. I say that this is the solution based on my work. Now, if I work well or not, this will be this I have to know by checking both equations. So I am asking, is now my solution the solution of the system or not? So I'm writing this solution because it is the only one. So is this the solution? And to find the answer, I have to write both equations of the system. So 2x plus 5y equals 1. And the other equation is negative 2x, negative 3y equals to 7. Now, I'm going to replace the variables by the values of my solution. So instead of x, I will write negative 19 over 2. Instead of y, I have to write 4. And now I will check. If the equation 2x plus 5y equals 1 is true, what does it mean? The equation is stating that the left side is equal to the right side. So the left side must be 1 in order for the equation to be a true statement. Now let's me work on the left and let's see. So let's me extend the fraction bar here. So 2 divided by 2 is 1, and 1 times negative 19 is negative 19, and 5 times 4 is 20, so I have 20 minus 19, 1. So 1 on the left, 1 on the right, so I have 1 equal to 1, a true statement. That means that my solution satisfied the first equation. So let's see if my solution will do the same thing to the second equation. So instead of x, I have to write negative 19 over 2. And instead of y, I have to write 4. And now my question is, by doing this, I must find the left sign to be 7, because 7 equal to 7 is a true statement. Now let's work on the left side and let's see. Let me extend the fraction bar here. So I have a multiplication, so 2 divided by 2 is 1. So negative 1 times negative 19 becomes positive 19. And negative 3 times 4 is negative 12. So 19 minus 12 is 7. So still the left side is equal to the right side. So I have 7 equal to 7, which is a true statement. So my solution satisfied the second equation, and hence my solution satisfied the system. Therefore, since my solution satisfied the system, negative 19 over 2, 4, is the solution to the system. Is the solution to the given system. Now, before I move to another example, I have to emphasize again. So when we added both equations of the system, and if the coefficient of one of the variables that we are interested to eliminate are opposites, then these variables will go. So we will be left with the other variable. Okay, transforming an equation in two variables into an equation in one variable that we can solve easily. So this is our goal, to add equations, and if we want to eliminate x, x must have opposite coefficient. If we want to eliminate y, y must have opposite coefficient. So keeping this in mind, let's continue our work. So again, in this example 2, I want to use the addition method, and for this I want to add both equations, okay? So first, before adding both equations, I will check the coefficient of x if I want to eliminate x. So the coefficient of x are not opposites. Positive 1 and negative 5 will never give me 0. So, but easily, I can make this positive 1 positive 5. How? By multiplying positive 1 with 5, I will get positive 5, and negative 5 together are 0, so x will be eliminated. Now, if I want to eliminate y, I pay attention to the coefficient of y. These are exactly the same numbers, so they are not opposite, but easily I can make For example, I want to change only the second 6. So I want to make this negative 6. How? By multiplying by negative 1. Okay? You can choose to change the 6 that is in the first equation. So I decided to change the 6 that is on the second equation. Okay? So by doing this, I have positive 6 and negative 6, which are opposites, and will give me a 0, so y will be eliminated. Now, I will have to choose x or y. So I'm choosing to eliminate y, so forget about multiplying by 5 here, and forget about addition for now. So, what I decided to change this positive 6 into negative 6 by multiplying 6 by negative 1. Now, I am not allowed to do this only here. I have to do this through equation. So, I have to show this. I want to multiply the entire equation by negative 1. And we know multiplying by negative 1 is just changing the signs through the equation. So, by doing this, I form a new system which is equivalent to the first one. So, the first equation, it is not changed, so I have to rewrite it. And the second equation is transformed now. The signs of the coefficient of x and y and the constant are changing their signs. So I have positive 5x, I have negative 6y, which I wanted, and I have positive 22. Now that I am sure that if I add both equations, y will be eliminated, I am going to add the equation, and I have an equation only on x. 5 plus 1 is 6x equals to 30. And now solving for x, I have to divide by 6, and x is 5, which is the first value of the coordinate of my solution. So, solution is 5. And I'm waiting to find the value of y coordinates. And to do this, I have to choose one of the original equations, so let me choose the first. You can choose the second, it doesn't matter. Still, we will find the same value for y. So let me rewrite the first equation. X plus 6y is equal to 8. Let me replace x with 5 to find y, subtracting 5 to both sides to leave y alone, and now I have 6y equal to 3, dividing by 6 both sides. Okay, 6 and 6 is simplified, but I can simplify 3 and 6 also. Why not? Dividing by 3 here. So y is 3 divided by 3, 1, 6 divided by 3, 2. So 1 value is 1/2. Therefore, the solution to the system is, let's write this correctly, x first, 5, y second. Done. Now let's go to example 3, and again, to use the addition method, I want to add both equations in order to eliminate one of the variables. So if I want to eliminate x, I pay attention to the coefficient of x, so they are not opposites. But easily, I can make one of them positive by multiplying by -1. So now I have -9, +9, opposite numbers, x will disappear. Now, if I want to eliminate y, so the signs are correct. One is positive, one is negative, but the distance from 0, the symbol of the numbers, or you can say the absolute value of the numbers, it doesn't matter. So simply the symbols are not the same. So I can make both of them 14 by multiplying by each other is the easy way. So I have to multiply 2 by 7 and 7 by 2. But this will give me to work on both equations. So I decide to eliminate x, because eliminating x will give me work only on the second equation, or if you want, on the first equation, but not to both of them. So forget about eliminating y, forget about addition for now. The only way it is to multiply the entire second equation by -1. Okay, because I am not allowed to multiply by -1 only one term in the equation and to violate the rules of the equation. If I want to do something at one term, I must do it everywhere on the equation. So by doing this, I form a new system equivalent to the original one, and I didn't work on the first equation, so the first equation is unchanged. So let's rewrite it. And now multiplying by -1 means I have to change the signs through the equation. So positive 9x, positive 7y, and -2. Okay, this is the job when we multiply by -1, just changing the signs. Now I am ready to add, because I know adding both equations, x is gone. This is what I did. And I will be left only in y. 7 plus 2 is 9y, and 20 minus 2 is 18. An equation only in y's, I have to solve this by dividing 9 to both sides. I have 1y equal to 2. So y is equal to 2, which is the coordinate, the second coordinate of my solution. So let's write here, solution is waiting for its values. So the second coordinate, the value is 2. The solution is waiting to find x to be complete. Now, to find x, I will choose one of the equations of the original statement. So let me choose the second. You can choose the first, it doesn't matter. Let me rewrite the second equation, -9x, -7y, and +2. Now let's go and replace y with 2 to find x. -7 times 2 equals 2. So I have -9x, -14. To leave x alone, I have to add 14 to both sides. And I have -9x equal to 16. Dividing by -9 to both sides, I get that x is -16 over 9. This 16 and 9 cannot be simplified, so I am done. This is the first value of my solution, the first coordinate. Therefore, I declare that the solution to the given system is, first write the value of x, and the second the value of y. That's it. So the solution is this pair of numbers in order. First we have the value of x, -16 over 9. Second we have the value of y, which is 2. That's it. Now let's go to discuss a third problem. Still, I want to use the addition method to add both equations in order to eliminate one of the variables. Now, if I want to eliminate x, I will pay attention to the coefficient of x. And I see that the coefficient of x are not opposite numbers, but I can make this positive 1 easily to a negative 3 by multiplying by negative 3. So negative 3 times positive 1 will give me negative 3, and negative 3 positive 3 are opposites. Together will give me 0. X will be eliminated. Now, if I want to eliminate y, I will pay attention to the coefficient of y. So they are not opposite numbers, and it is so I have to work in both equations to make those two numbers 10. And then change the signs of 1, and I will have opposite numbers, but this will give me work on both equations, so I will choose to eliminate x, which is easier, to work only on the first equation. So forget about changing the coefficient of y, so forget about eliminating y and forget about the addition right now. So let me manipulate the first equation by multiplying the entire equation by negative 3, not only the coefficient of x. So doing this, I will find a new system equivalent to the original one when the first equation is changed. Negative 3 times positive 1 is negative 3x, negative 3 times negative 2y is positive 6y, and negative 3 times 10 is negative 30. So the second equation is as it is, so let's rewrite it. And now that I am sure that x will be eliminated, I am going to add both equations. X is gone, negative 3 and positive 3 is 0, x disappears, so I am left only with y's. 6y minus 5y is 1y. And negative 13 plus 4 is negative 26. We subtract from 30, we keep the sign of 30. 30 minus 4, 26, negative. And this is the second value, the second coordinate of my solution. Again, the solution is waiting for the coordinate value. So I have to write in the second position negative 26, so I have to find the value of x. And to find the value of x, I have to choose one of the original equations. So let me choose the first. Write it down, x minus 2y equals 10. Let me replace y with negative 26 to find x. So I have x minus 2 times negative 26 equals 10. X negative 2 times negative 26 becomes positive 52 equals 10. I remove 52 by subtracting 52 to both sides. So x is negative 42, which is the first coordinate of my solution. So I have both coordinates of the solution found, and I have to write the statement now. The solution to the system is in order: first x, negative 42, and second y, negative 26. So this solution will make my system true, and it is the only one. So let's go and solve the problem 5. Again, I want to add both equations in order to eliminate one of the variables, and I'm looking at the coefficient of x if I want to eliminate x. So the coefficient of x are not opposite numbers because positive 2 and positive 5 together give me positive 7. Also, the coefficient of y are not opposite numbers because even though they have opposite signs, the distance from 0 is different. So if I want to eliminate y, In this condition, in this condition, neither x, neither y cannot be eliminated. So I have to choose to eliminate x or to eliminate y. As we see, both x and y will give me to work on both equations. So I am choosing to eliminate y. Okay. If I choose to eliminate x, I have to make these numbers both 10, and one of the numbers will be multiplied by a negative 1 to become positive 10 and negative 10, okay? So already I have the signs here, so my job in y's is only to make those numbers 21. Multiplying 7 by 3 gives me 21. Multiplying 3 by 7 gives me 21. So forget about manipulating the coefficient of x, forget about the addition. So let's multiply by let's make the symbols of the coefficient of y's both 21. Okay? So this idea suggests that I have to multiply negative 7 by 3, and this will be negative 21, and I have to multiply 3 by 7, and this will give me positive 21. I'm not allowed to do only here, so I have to do it through the equation. So let's go and form a new system equivalent to the original one. And now, in this example, I'm manipulating both equations. So multiplying by 3 through the first equation, I get 3 times 2x, 6x. 3 times negative 7 is negative 21y. And I have 3 times 19 is 57. And so I have to multiply by 7 through the second equation. 7 times 5x is 35x. 7 times 3y is positive 21y, exactly what I wanted when I thought to eliminate y. And 7 times negative 14, it is negative 98. Now I am ready to multiply both equations, because doing so, y will be eliminated. So I have 6 and 35 is 41x equals to, this is negative 41. 98 minus 57 is 41, and we keep the sign of 98. Dividing by 41, both sides, we get that x is negative 1. Let's go quickly. Write the solution point, because the solution point is waiting to put the values there. So negative 1 is the first number, the first value, the first coordinate of my solution. And now I have to find what is y. What is y? I have to find it out by choosing one of the original equations. So let me choose the first one. You can choose the second, it doesn't matter. So let me write the first equation, 2x minus 7y equal 19. Let me replace x with negative 1, the value of x that I just found. And I have 2 times negative 1 minus 7y equals 19. I have 2 times negative 1 becomes negative 2. Adding 2 to both sides to leave y alone. So now I have negative 7y, which is equal to positive 21. Dividing by negative 7 to both sides, I get y is negative 3, which is the second value in my solution. Okay, so I declare this is the solution, but let me write it. So this solution to the given system is in order: x first, and y second. -1, -3. That's it. This pair of numbers, if will be replaced for the variable, if we substitute the variables into the original system becomes a true statement. This is the job of the solution. This is the only one. So in all these examples, we saw that these systems have only one solution. Okay? Keep in mind, if you are able to find the value of one of the variables, immediately you understand that the system has only one solution. Let's look at another example. Still again, I want to add both equations in order to eliminate one of the variable. So now if I want to eliminate x, I have to make the coefficient of x opposite numbers, so I have to work on both equations to make one positive 6 and the other negative 6. So I have to work on both equations if I want to eliminate x. When I look at the coefficient of y, so the coefficient of y in the second equation, it is -1. Okay, so 1 easily can become 4 by multiplying by 4. So multiplying 4 and 1, I will get 4, and the signs are correct. So I have +4, -4. If I add both equations, y will go. So eliminating y is my decision. Why to work on both equations if I have a chance to work only at one of the equations? So, as always, as we said before, I'm not allowed to multiply only the coefficient of y. So forget about the addition. I am going to multiply by 4 the entire second equation. Okay? Not only the coefficient of y where I have interest. Now, doing this, I have to form a new system equivalent to the original one. When the first equation is not changed, so I have to rewrite it. And the second one is multiplied by 4, which means I have to multiply the coefficient of x and y and the constant by 4. 4 times 2 is 8x. 4 times -1 is -4y. And 4 times -5 becomes -20. Now I'm ready to add both equations because I worked to eliminate y and I achieved it. So I have 3x plus 8, it is 11x, and I have 20 minus 20 is 0. So dividing by 11, x is 0. 0 divided by any number that is not 0 is still 0. So the solution is happy. We found the first coordinate, which is 0. And now we have to find the second coordinate of the solution, which is the y value. And to find the y value of the solution, we have to choose one of the original equation. Let me choose the second. It doesn't matter, you can choose the first. So I have to write 2x minus y equal to -5. I have to replace x with 0. And now I have 2 times 0 minus y equals -5. 2 times 0 is 0, so I am left with -1 equal to -5, dividing by -1 both sides, because the coefficient of y is -1, so I have y is equal to +5, which is the first coordinate of my solution. Okay, therefore, the solution is in my hand, and I declare that this solution to the system is a pair of numbers in order 0, 5. X is 0, and y is 5. That's it. Let's work on the example 7. To use the addition method, I want to add both equations. And if I want to eliminate x, I see that the coefficient of x are not opposite numbers. 2 and 3 is 5, so I have to manipulate both equations. And when I look at if I want to eliminate y, and the coefficient of y's are not opposite. So they are -2, -3 is -5 if I'm going to add. So I have to choose now to eliminate x or y. It doesn't matter. Even though we choose x or y, we still have to work on both equations, so I'm decided to eliminate x. Okay, so in order to eliminate x, I have to make both numbers 6. And I know if I multiply 2 by 3, I make this 6. If I multiply 3 by 2, I will make it 6. But they are both opposite, so I have to change the signs only at one of the coefficients. So let me change the second one to make this -6 and this +6. And still, never forget that you have to multiply through the equation. Let me destroy this 6, because when you multiply, maybe you go and multiply that 6. So let's write the new system. So 3 times 2x is 6x. 3 times -2y becomes -6y. And 3 times 8 is 24. -2 times 3x is -6x, which I wanted. -2 times -3 is +6y. -2 times 12 is -24. Okay, now I'm going to add both equations, knowing that x will be disappear because this came as a result of my ideas and my work. But we see here that y is going to be eliminated too, because the coefficient of y are opposite numbers. You see, +6, -6 is 0, so y disappears. On the left, we have 0. And on the right, they are opposite numbers too. 24 minus 24 is 0. So, working to solve the problem, I came in a true statement. So this work shows me that in this system, the left side is equal to the right side. And this means that both equations, the left side is equal to the right side, the left side is equal to the right side, okay? So the system is true for all values of x and y, and I have to write down. So this leads to infinitely many solutions. So if x and y disappear from our work, this means that there is, as in compared to the other cases, so there we were able to find a variable after elimination, value for the variable that was left, and immediately we knew the system had only one solution. Now that both variables disappears from our work and we get a true statement, immediately we know that this system is true always. So for infinitely many solutions, and the solutions are in the form xy, where x and y are real numbers. That's it. So the system has infinitely many solutions where x and y are real numbers. Paired together in order, they make always the system a true statement. Let's go and look at the example 8. So to use the addition method, I want to add both equations in terms to eliminate one of the variables. So if I want to eliminate x, I have to make this number opposite, so they are exactly the same number. So we have positive 2, positive 2. Easily we can make this negative 2 by multiplying by negative 1. So I am deciding to eliminate x by multiplying the second equation by negative 1, which means changing the signs through the equation. So I have now the first equation is unchanged because I didn't work there, and the second is just changing the signs, negative 2x, positive y, and positive 4. Now that I know that x will disappear if I add both equations, I want to continue, but I see that since y has opposite coefficient, y disappears also, so I'm left on the left with 0. And on the right, I get 4 plus 4, 8, which is false statement. Which means that the system has no solution. Because x and y are not real numbers. Okay? We cannot find any value for x and for y paired together to make this statement true. This statement is always false, which means this statement, this system, is always a false statement. For real numbers. Now, let's look at the example 9. So again, I want to use the addition method. I have to add both equations in order to eliminate one of the variables. So now looking at x, if I want to eliminate x, so I have negative 4, negative 2, they are not opposite, but I can change one sign, make one negative, one positive, or this positive and this negative, and 2 easily can become 4 by multiplying by 2. So 2 times 2 is 4, and if I want to change the signs, I have to multiply by negative 2. Negative 2 times negative 2 becomes positive 4, and I have negative 4 times negative plus 4, which is 0, sorry. And looking at y's, I have to manipulate both to make them 12 and change one of the signs, okay? But why to work in both equations when I can work only on the second equation? So I'm choosing to eliminate x, forget by eliminating y, forget about the addition for now. So let me multiply the second equation by negative 2. You can multiply the first equation by negative 1 and multiply this by positive 2, but why? I am doing only why to do 2 works on both equations. Okay, so take it off, because we are not allowed only to change the coefficient of x, but we have to multiply by negative 2 through the equation. And doing so, let's write the new system. The first equation is unchanged. The second equation will be changed. Negative 2 times negative 2 is positive 4x. Negative 2 times positive 4 is negative 8y. And negative 2 times negative 10, it is positive 20. Now that I know that x will go, by adding both equations. I am left only in y's. Negative 8 and positive 3 is a subtraction. Subtract from 8, keep the sign of 8. 8 minus 3, 5 y's. And I have to subtract from 10, from 20. 20 is positive, so I get 20 minus 10, positive 10. Dividing by negative 5 both sides, I have y is equal to negative 2. Now, I'm going back to the question, okay? So I was rushing up and I didn't pay attention to the question, okay? Because all the examples were solve the system, solve the system, solve the system, and immediately I went to solve the system, okay? And I was lucky because the question of the system is exactly the job that I just did. So the question of this problem is a little bit different from the other question. Here is to find the value of the y coordinate. So what this means? This is asking us not to do two jobs, just to do only one job, to find the value of the y coordinate, not x. So the question is asking only for the half of the job, okay? So luckily I did this work, but if I was not lucky, I will continue to find the answer. For example, if I choose to eliminate y, my equation will be left on x, and first I could find the value of x, okay? But still, to find y, I will do the same job to find the complete solution. In other words, pay attention to the question of the problem, okay? So, find the value of the y coordinate means keep the value, keep y and eliminate x. So there is no choice, as we had before, to eliminate which we wanted. In this kind of question, this is an order. Keep y and eliminate the other, okay? An order to help us, because it is not an order that if you don't do this and they will punish you, but it is to help us. Just do the half of the job. Keep y and eliminate x, okay? And really I did this without noticing the question at all, okay? It was the routine. Now let's go back and read the other, let's write the question here. Here is solve. Solve the system. And when the question is solve the system, we need both coordinates. We have to find both values of the coordinates, okay? But when the question specifies which value is needed, so we have to do only the half of the job, and I am done here. I gave the answer to the question. So the answer is the y coordinate. You don't need to write it. Of the solution to the system is -2. This is the answer. You don't need to write, just check it and you are done. Now let's go and read example 10. Now I know that I have to read the question. Students all the time don't read the question, okay? And when you don't read the question, you do a double work, which is not needed. So now I pay attention to the request of the problem. So find the value of the x coordinate. So the job is to find only what is x and not y. Only one job, the half of the job, okay? So let me separate this. I'm not asking to find y. I want to find only x. And this means that I need x. Since I need x, I have to eliminate y. No choice to eliminate x or y. It is specified, keep x and eliminate y. How we can find x? Only if we, after we eliminating y, we have an equation in x. And x, the equation will tell us the value of x, okay? So now it is in order to help us why to do a double job, just keep x, eliminate the other. So the intention is to eliminate y, and to eliminate y, I need opposite numbers, so I have exactly the same sign. So let me change the second sign by multiplying by -1, okay? And now I have a job to make these two numbers, 2 and 5, the same number, and the idea is to make them 10 by multiplying by each other. So to make 2 10, I'll multiply by 5 the first equation. And to make this 10, I have to multiply by 2 the second equation. So what I'm doing here, I multiply by 5 through the first equation and by -2 the second equation. The negative sign will change me the sign of the second coefficient of y, and 2 will change me the symbol, the distance from 0. That's it. Now let me rewrite the new system. I have 5 times -2x, which is -10x, 5 times 2y, which is +10y, and 5 times 0 is 0. -2 times -2 is +4x, -2 times 5y, it is -10y, and -2 times 3 is -6. Now that the y has opposite coefficient, I am going to add both equations because y will be eliminated. I am left only on x. X is happy, and I am done. Let's continue a little bit work. -10 and +4 is -6. Subtract from 10, keep the sign of 10. So we have -6x. And 0 and -6 is just -6. Adding 0 to a number doesn't change the number. So dividing by -6 both sides. So I have x is +1, and I am done. Okay, so let me write the answer down. The value of the x coordinate of the solution to the system is 1. Done. So thank you very much listening to this video, and I hope this will help you to work on the homework. So these 3 videos, the first, the second, and the third, were about how to solve a system of equations in 2 variables. Okay, so I see you in the next video when I will discuss how to graph linear equations in 2 variables, linear inequalities in 2 variables. So thank you very much again. See you later.